Okay, so we're going to go ahead and go over the 1998 AB, one of the free responses, specifically number 3. So you should all have this free response in front of you at this time, and if you don't, go ahead and ask the sub to hand you one. Okay, all right, so number 3 says this: the graph of the velocity, that's important, the graph of the velocity v of t in feet per second of a car traveling on a straight road for 0 to t to 50 is shown above. A table of values for v of t at 5-second intervals of time is shown to the right of the graph. All right, so they've given us a graph and they've given us a table. Letter A says this: during what intervals of time is the acceleration of the car positive? Give a reason for your answer. So let's start with letter A. Okay, so the first thing that we need to remember here is what is the relationship between velocity and acceleration? Think about that for a minute. Okay, so hopefully we know that if I take the derivative of velocity, I get acceleration. If I take the derivative of velocity, I get acceleration. It's asking me about acceleration. So in essence, what this is asking me is they're basically asking me about the derivative of the velocity graph. We want to know when is the acceleration positive. So in essence, what I want to know is when is v prime of t greater than 0? Well, v prime of t tells me the slopes of all of the tangent lines from 0 all the way to 50. V prime of t is the derivative. The derivative tells me slopes. So looking at this graph, where are all of the slopes positive? From what interval to what interval are all of my slopes positive? Go and write that down if you know what it is. Okay, so we should see that from 0 all the way up until 35. So from 0 all the way up until 35, if I even use my pen, I can see that its slope is always positive. So from 0 to 35, I'm getting a positive slope. And I also, don't forget this very tiny piece here, I'm also getting a positive slope from 45 to 50. From 45 to 50. So what we can say is that the acceleration is positive, which means the derivative is positive. The acceleration is positive on 0 to 35 and 45 to 50. And it says that we need to state a reason. It says give a reason for your answer. So when this is being graded on an AP assessment, you're getting 2 points for your answer. You're getting 1 point for this right here, and you're getting 1 point for this right here, but there is there is a third point, which is give your reason. So there are a lot of different ways that you could defend your reason, but what you could probably say here is we could say because the velocity v of t is increasing. We know that acceleration will be positive because velocity is increasing on the interval 0 to 35 and 45 to 50. That is letter A. So hopefully at this point in our AP career, we should be able to get a question like this. If I'm relating velocity to acceleration, I should know that they're related by one derivative, either a derivative or some sort of integral. So that's letter A. All right, letter B. Find the average acceleration of the car in feet per second squared over the interval 0 to 50. Okay. When I see the word average, I should have a couple things come to my mind. What are we taking the average of? Well, we're taking the average of the acceleration. And the acceleration, if I think about the way, once again, how v is related to a, or how velocity is related to acceleration, well, acceleration is the rate of change of velocity. So what they're really asking for is what's the average rate of change? What's the average rate of change of v of t? That's what it's asking. What's the average rate of change of v of t? So at this point in time in your calculus career, you should know how to do this, so I'm going to give you just a moment to try and find the average rate of change. Okay, so if you are just wrapping that up or you're just still working, that's okay. I want to go through how we can find average rate of change. In essence, we're looking for the average acceleration. That's the same thing as the average rate of change of the velocity. So we can say that the average acceleration is going to equal, well, what it's going to equal is basically just the slope from the beginning point to the end point. So my beginning point is just the point 0, 0, and it looks like my end point is at 50, 70? Is that 72? I think it says it on here actually. Here we go. Yeah, so you want to be careful here. We're not just eyeballing. They did give us a table. It says that we have the point 0, 0 here in the table, and if you're unsure as to what that point is, like I was, you can always look in the table, and it says that it's the point 50, 72. So good call. Close call there. 50, 72. So all this is really asking us to do is go ahead and find the slope of the line that goes through 0, 0 and 50, 72. So what that's going to be is v of 50 minus v of 0. So that's basically y1 or y2 minus y1 all over 50 minus 70, minus 0, my goodness. 50 minus 0, that's my x2 and my x1. Well, I know that v of 50 is going to be 72. And I know that v of 0 is going to be 0, and so I get 72 over 50. Get 72 over 50, and that right there, that is going to be my average acceleration. That is the average acceleration. So that's the average acceleration. That's letter B, my average acceleration. And just note here that they want this to be in feet per second squared. So that right there is letter B. Okay. Let's give myself a little bit more room. All right, so let's go ahead and move on to letter C. It says, find one approximation for the acceleration of the car in feet per second squared at time 40. Show your computations that you use to arrive at your answer. Okay, so let's go ahead and take a look at where t is 40. Let's see, t of 40 is right here at 75, so t of 40 right here is right there at about 75. So in order to find the answer to this question, well, let's look what it's asking for a minute. It says find one approximation for the, not the velocity, for the acceleration of the car. So what this is looking for, is basically what is an approximation of the slope of the velocity graph at 40. Now, if we knew the exact equation, I could just take the derivative and evaluate at 40, but I don't know the exact equation, so I need to think back to what does a derivative mean? Well, a derivative means the slope of the tangent line. So what I'm really looking for is at 40, what is the slope of the tangent line? So there's my little rough picture there. The slope of my tangent line at 40, well, number one, we know it's negative. It's got to be negative no matter how you draw that tangent line. It has to be negative, so let's just keep that in mind. There are a lot of ways to approximate this. In fact, on the AP test, I'm looking at the answer sheet now, and it looks like there are about 3 or 4 answers that they have on there. There are a lot of acceptable answers to this question because it is an approximation. So if you're thinking to yourself, how could I approximate the slope here? What do? What do you need in order to find a slope? Well, you need at least 2 points to find a slope. You need 2 points to find a slope. So if I take a look at my table, I want to know what is the slope approximately at 40. Well, what I could do to find the slope at 40 is I could use a whole litany of different points, but maybe I would do this. Maybe I could take the point 35, 81, and I could take the points 45, 60, and because 40 is sandwiched between 35 and 45, this would actually be a decent approximation of what the slope would be at 40. So let's go and calculate this one. So in order to calculate the slope, all I'm going to say is v of 45 minus v of 35, all over 45 minus 35. So what we're going to get there is, if we just use our points here, we're going to get 60 minus 81 all over 10, which is going to give us negative 21 over 10. And they want it in feet per second squared. So that is one solution. There's actually a lot of solutions. You could have done v of 40 minus v of 35 all over 40 minus 35. You could have done, let's see, v of 40 minus v of 45 all over 40 minus 45. There's a lot of iterations that you could have used here to get the correct answer. All that we really are looking for here is that you're giving an accurate approximation to what the slope could be. So that's letter C for you. All right, so we are almost done. Let me fold this over so you can still see. We are almost done here. We're almost done. All right, last one, letter D. Oh, this is exactly what we've been working on in class, so this is super exciting. It says this: approximate the integral from 0 to 50 of v of t with respect to t with a Riemann sum. Ooh, Riemann sum, very fun. Using midpoints. Oh, okay, that might be semi-familiar to us. Midpoints of 5 subintervals of equal length. Using correct units, explain the meaning of the integral. Okay, all right, we can for sure do this first part. The second part, explaining the meaning of the integral, this might be new for us, so we'll talk about it. But let's start with the first part. So for letter D, okay, so it's asking us to make a Riemann sum. So if I remember back to just like about a week ago, we learned left and right Riemann sums. So Riemann sums are rectangles that approximate the area under a curve. They approximate the area under a curve. So if I want to use Riemann sums to find the area under this curve, I need some information. They told us, number one, we're not doing a left Riemann sum, we're not doing a right. They said we're using midpoints. So we'll come back to that. And it says we're using 5 subintervals. So let's start with this. How big should my rectangles be if I'm only using 5 of them? Well, let's think about this. I'm going a total distance of from 0 to 50. So I'm going a total distance of 0 to 50, and I want 5 subintervals. Well, how many rectangles can I fit? What is the length of the rectangle that I could fit from 0 to 50 if I could only use 5? Well, what that's just going to be is going to be my total distance, 50, divided by however many rectangles I have, which in this case is 50 divided by 5, which is 10. It's 10. So what this is saying is that each rectangle will be 10 in width. It will be 10 in width. All right, so that's the first piece of information. Second piece of information, it says we're using the midpoints of them. So what do you suppose that means? So there's left Riemann sums, there's right Riemann sums. A left means we start at the left-hand corner, and right means we start at the right-hand corner for my height of the rectangle. So a midpoint rectangle is just one that's height starts at the midpoint of the rectangle. So for a left Riemann sum, your height would start here, For a right Riemann sum, your height would start here. And so what they're saying is that a mid Riemann sum just has its height that starts in the middle. So let's go ahead and figure this out. So I'm gonna go ahead and, I wish I could zoom in, can I? Oh, this is on my phone, FYI, so hopefully this isn't janky. All right, so I need to have rectangles of width 10. Well, this thing is scaled by 5, so let's go ahead and mark this off. I'm gonna have a rectangle here, rectangle here, rectangle here, here, and lastly a rectangle here. So what this is saying is that the height of my rectangle needs to start at the midpoint between the width of my rectangle. Well, the midpoint between the width of my rectangle is going to be right here for the first one at 5. So notice how I have a rectangle whose height starts in the middle of the rectangle. If I go up again, I'm going to have another height that starts at 15. If I go up again, I should have another height that starts at 25, which is in between. Go up again, I should have another height that starts at 35. 35. And lastly, oh man, I really drew on this, so it's kind of hard to see. I think it's right here. We should have a rectangle that starts at 45 right here. So all we need to do, this question is actually not very difficult. It might take you a minute to add them up, but it's really not difficult. All I'm doing is I'm taking all of these rectangles and I'm adding them up. I'm just taking all these rectangles and I'm adding them up. That is literally all I am doing. So let me zoom out. Hopefully this works, okay? So what I'm doing is I'm just basically adding up all of these rectangles. Well, in order to save just a little bit of time, I know every single rectangle is going to be multiplied by 10, so I'm going to put 10 out front. And hopefully this is a little bit familiar. So the first rectangle has a height of 5. I'm not even going to write it yet. I know that the height of 5 is just whatever the function is at 5. So we can say v of 5. Oh no. And then we'll say plus v of 15 plus v of 25 plus v of 45. I'm about to lock 9th period out. Oops. If I go onto my table and I check what the values are for v of 5, v of 15, v of 25, and v of 45, I get these values. So I get these values. 12 plus 30 plus 70 plus 81 plus 60, and if I sum them all up together, I get 2,530 feet. So that is the Riemann sum approximation with 5 rectangles using midpoints that approximates the area under this velocity graph. We're going to come back in just a minute to do the very last piece of this question.